Hi everyone, thanks for joining today's session. I'm going to talk a bit more about data replication in Azure SQL and beyond. And what I mean to beyond is that we'll also explore some solutions available on SQL Server in Azure SQL databases and Azure SQL managed instance. So I'm a program manager in the Azure SQL department at Microsoft. Okay, so let's get started. So for today's agenda, we are going to very high level and quickly discuss why is data replication relevant. And then we look at some common scenarios and solutions that we've seen our customers use for replication needs. And then we'll explore some of the solutions in more depth. Given the limited time, we'll only have time to explore 4 of these solutions, and we'll do 2 demos as well. So we look at change data capture, SQL Data Sync, change tracking, and transactional replication. And lastly, we are going to wrap it all up, bring it all together, and do a comparison of these replication technologies. So at very high level, why is data replication relevant? Well, there are so many scenarios for replication all over the world in so many industries. Like you might have a business that has offices and inventory in different regions of the world, and you want to make sure that all the bases in all these regions stay synchronized to the inventory. So you might use data replication technologies. You might be a 911 system that has to very quickly displace resources within a country, and you have to be aware of all the needs at all points in time. So you would need real-time or as close to real-time replication to be able to very quickly react to people's needs in different parts of the country. There might be a disaster in one of your regions, so you want to make sure that your database gets quickly shifted to another one to save all your data. So there are so many scenarios for replication, and we are going to explore some of them today. So as I was telling you, we've seen our customers use replication technologies for multiple scenarios. So you might want to synchronize your distributed applications or workloads that are globally distributed. And here you might want, for instance, for the distributed applications, you might store different workloads, so one production database and another analytics workload database, and you want to make sure those are synchronized. For such needs, you have several solutions like sync, change data capture, change tracking, transactional replication. We are going to explore all of them today. And then on the business continuity side, this refers to the procedures enabling you to continue operating in face of disruption. So if there is a data center outage, application upgrade, anything like that, there are some solutions. Unfortunately, we don't have time to go into this today. Then you might want to scale out your read-only workloads. So you want to offload read-only workloads instead of running them on the read-write replica for performance purposes. And lastly, you might just do data migrations from on-prem to Azure, and you might want to use some of our technologies. So just a quick heads up, this is in no way a comprehensive list. There are so many more replication technologies that we have both at Microsoft and third-party great tools out there. But today we are just going to focus on these ones. Okay. So let's get started. So we're going to look more at change data capture. So change data capture helps you record data modification language changes. So as you can see in this diagram, you first enable change data capture at the level of the database that you want to track changes for. Once you enable it at the level of your database, you look at the source tables and you enable it at the level of each table that you want to track for changes. Once you do that, all the changes in your source tables that are tracked go to the transaction log, and from there are two jobs, a capture and a cleanup job. They are SQL Server Agent jobs in Azure SQL Managed Instance and on the SQL Server version of CDC. We'll go into the Azure SQL Databases CDC soon. So these two jobs that are SQL Server Agent jobs capture the capture one takes changes from the transaction log and adds them to the change table. So for every source table you enable for CDC, you have an automatic change table being created for it, an associated CDC table. So all these changes are taken by the capture job from the transaction log and added to this associated CDC table. However, there's also a cleanup process, a cleanup job, which is also powered by the SQL Server Agent, and that cleanup job cleans these change tables based on a time-based retention policy. And lastly, once you have all your changes in the CDC associated tables, you have query functions that you can use to consume the change data from the CDC change tables. And afterwards, you can stream these changes to other external destinations if you prefer, or you can keep them in the same database and run some analytic workloads on them. We'll look into more details soon. Okay, so I was telling you for CDC in Azure SQL databases, which is currently in public preview as of this summer, we have a CDC scheduler that replaces the SQL Server Agent, right? So the cleanup and capture jobs are being replaced by CDC scheduler, which automatically runs cleanup and capture on your database. So you can safely assume that they are being run on the background. However, if you still want to manually execute scan or cleanup, you can still use the same stored procedures on demand. So that's the main and only difference that you see for change data capture in Azure SQL databases relative to CDC in SQL Server or on Azure SQL managed instance. So here are some of the key CDC use cases. So you might want to track data changes for audit purposes. You might want to propagate changes to other downstream subscribers. You can do ETL operations to move the changes from your OLTP system to data lake or data warehouse. And for this, if you want to downstream like changes, you might decide to use Azure Data Factory, for instance. You might also want to perform analytics on change data or do event-based programming to have like instantaneous responses based on data changes. And here you might have an application that does dynamic pricing. So that would be very, very helpful. Great. So bringing it all together for CDC, we have some key concepts that are worth understanding. And afterwards, we are going to go in a demo. So first of all, as I was telling you, we have the capture and the cleanup processes. The capture one scans the log for new change data, while the cleanup cleans the change tables based on a retention policy. However, you can also run this manually or by the scheduler if you're on Azure SQL databases. Then you have the change table. So for every source table enabled for CDC, you have an associated change table created. Then you can do monitoring. So these are two DMVs that you can use to monitor CDC. Then you have table valued functions. So these allow you to take the changes over a specified range and to return that form in a filter result set. So you get all changes by default. You can also enable it such that you get net changes. And we'll see in the demo how you can do that. And lastly, we have log sequence numbers, which is really important. And this one identifies changes that were committed within the same transaction and orders those transactions. So that's on the transaction log side. CDC uses as LSN. Okay, great. So if you want to actually enable CDC on your Azure SQL databases, as I was mentioning, you first start at the database level. And once you enable this at the database level, you have 5 artifacts, which are these 5 system tables that get created on your same database. So it's very important to make sure before you start using CDC that you have enough space, given all these additional artifacts that CDC creates on your database. And also something to note for Azure SQL databases is that CDC won't work if your databases are in the S3 tiers, which is like standard 3 or below. So for instance, it won't work if you have a basic tier database. So once you enable CDC at the database level, you get these 5 system tables. So the first one, list of capture columns, list of tables that are enabled for capture, and the DDL history table. Then you can see the indexes associated with this change table, and lastly, you can see the mapping of LSN number and time. Once you do enable CDC at the database, you also enable it at the table level. This is what you would run to do that, and the moment you do that, your capture and cleanup get created, and there is a table to track changes on your source table. So if you do this on SQL Server or Azure SQL Managed Instance, you must ensure that your SQL Server Agent is enabled for these 2 jobs to run. Great. So now let's do a demo for CDC on Azure SQL databases, which as of now is in public preview. Great. So here you can see I have a test database which only has 1 table and 1 customers table and 1 record in it. So I enable the database for change data capture, as you can see. And now I'm trying to show you that the system tables get created the moment you do that. So you have 5 additional tables in the system being created, which we just discussed about. So you can see the capture columns table, because you can select which columns to enable CDC for, and we're going to do that soon. The change tables, the DDL history for the DDL changes done in the past, index columns, and the LSN time mapping. Obviously, these will be mostly empty because we just started. So now let's see what we have in our customers source table, which we want to enable for CDC as well. It's just one very simple record. So I want to enable CDC at the level of this table. So I run this, and as you can see, you can also, here is where you decide if you want to support net changes. You automatically get all changes by default. And here you can select which columns to track. In my case, I want to track all columns. So once I do this, you can see that I have a new table, which is CDC DBO customers CT, which gets created for the associated source table that was enabled. And you can also see that I have the jobs showing up, the capture and cleanup jobs. There you can see where the table was created. And here you can see the default parameters for the jobs, which you can change, and we'll do that quite soon. So now I just want to insert a new customer on my source table and see if that gets identified by change data capture. And you can see it automatically. So the scheduler runs the scan automatically and takes the changes from the transaction log and adds them to the associated CDC table. However, you can still run manually the scan if you prefer to do so. So this still works. And here, as I was telling you, I want to change some of the parameters for CDC, some of the default ones. So let's say I want the retention policy to be changed. So I just did that. And as you can see, if you go back to the CDC jobs table, you can see that has been changed there. So based on your needs, you can alter these CDC parameters. So now, very simple. Now I just want to disable CDC on my table. So I want to see which table is enabled for CDC in case I would have more, let's say. So this is why I ran this command. And I can see that there is a parameter for CDC specifically. To find the table is tracked by CDC. So I found which table it is, and then I disable it at the table level and then at the database level. However, you can go ahead, disable CDC automatically from the database level, and that will be all good. You don't have to do both necessarily. So this is pretty much what I wanted to show you to get an idea of how CDC works on a very, very simple example on Azure SQL databases. Okay, so let's move onwards. So now we are going to look at SQL Data Sync, which is a different replication options, which actually allows both unidirectional but also bidirectional replication. So it allows you to synchronize data across Azure SQL and SQL Server on-prem or on your VM. And the whole concept of sync revolves around this idea of a sync group, which consists of a hub database and potentially one or more member databases. So the one requirement is that your hub database is always an Azure SQL database. However, your member DBs can be both either on Azure SQL DB or on SQL Server on-prem, for instance. So it doesn't really matter where your member DB is. However, hub has to always be on your Azure SQL DB. So there are some key concepts and properties for sync groups. So first you have the sync schema, which specifies what are the tables that will be synchronized within a database. Then you can choose the sync direction. So whether you want a one-way replication or bidirectional, so the sync can happen from member to hub, hub to member, or both. So what's very important is to recognize that sync has a hub and spoke model. So all the changes from the members get to the other members by first going through the hub. So that's how SQL Data Sync works. Then you can also configure the sync frequency. So here you might decide to run sync manually on an on-demand basis, which is totally fine. However, you might also decide to do it automatically. So when you go in the Azure portal and configure your sync group, which we'll see in a second for a demo, you can say, I want sync to be triggered every 30 seconds or even every 30 days, which totally works. However, it's worth noticing that there is a latency for all these sync changes. Even though you set up the frequency is not the same as latency. The frequency is how often do I want my sync to be triggered. And lastly, I have a conflict resolving policy. So here are two options in sync, either member wins or hub wins, as you have data conflict changes. Great. So as you can see here, there is a sync local agent for SQL Server. So if you have members that are on-prem, you must use this. So basically, when SQL Data Sync service communicates with the agent, it does so using some encrypted connections and the unique agent key. So the SQL Server databases authenticate the agent using this connection string and agent key, and this design provides high level of security for your data. Great. One last thing that I wanted to mention about sync is that you have a private link as well, which is being used for the sync service to connect to your hub and member databases. And this offers a secure connection. However, you can only use sync private link if your member and hub databases are all hosted on Azure SQL and in the same cloud type. So basically all of them in the public cloud or all of them in the government cloud. Some common use cases that we've seen sync being used for are hybrid data synchronization, distributed applications, and globally distributed applications. And we also already discussed about these ones in the beginning. And now I'm going to do a demo for the globally distributed replication scenario with sync. So in this demo, we are a business that has inventory across two separate regions around the world, one in the US and another one in Asia. So what I want to do is to make sure that those two databases across these two regions are constantly in sync. and I will want to do bidirectional sync. So my US database is going to be the hub, and the Asia database will be member, and changes will be shifted from one to the other and back, because it's bidirectional. So let's see how that would work. So I have in the Azure portal, very simple. I'm just showing you what I have in the demo. In the hub database, I have 4 items in my inventory in the US. And then I have a Asia member database, which only has 3. So as you can see, I need to synchronize one of my last items that was recently added to US to the Asia database. So I go into the sync product databases to create a new sync group. And here I set up the sync name, US to Asia. It's usually recommended to set up a new metadata database, which has to be in the same region as your hub database. So that's something to keep in mind. And for the pricing tier, I'll just put it as a basic database. This is a very small, simple workload. I'll use the default collation. So here I can choose, do I want automatic sync? And I said, yes, I want sync to be triggered every 2 seconds with the hub win conflict resolution policy. And I want to use private link for security purposes. Here you can learn more about it. And I create the sync group. Very important, for your sync group to be created, you must manually approve the private link between the hub and the sync service. So what we have to do right now is to go to the manual approval, see you have a pending private endpoint connection, which you have to manually approve. So we are approving that. Only once we do that, the sync group gets created. Then I want to add some members. So I have to log in on my hub database with the server credentials, and I want to add a member database, which in my case is also Azure, and it's in Asia. So I select the server to which this database belongs. I select the database, and I select that I want bidirectional sync from hub to member, member to hub, and I have to log in on the server side as well. Again, I use private link between the sync service and this member database for security reasons, but again, I have to manually approve it before the member gets added to the sync group. And because of that, I'll show you a different way to approve a private endpoint connection through the Azure portal. So you can go on the server side for that Asia database, go into private endpoint connections, and there you can see all your pending ones. So I want to approve this one manually such that I can continue using sync. Great. All good. Let's move onwards. This is taking a bit of time. Once I've created a single with the hub and member, I can go and select which tables I want to synchronize. So I refresh the schema. As you can see, for our simple workload, we only have 1 table. Just a second, which has 3 columns. So I just select that I want all columns synchronized. And then I have to do the same for the member database. It's loading, same. I have a primary key, which is good. And now I get to the sync group. So the sync group has been created. As you can see, it shows up in my sync groups. It has 2 databases, member and hub, 1 table that is being synchronized across this. You can see some logs for monitoring purposes in the portal. And now I want to see, has my additional inventory item from the US actually been synchronized to Asia? That should have already happened since I set up such a low sync frequency, right, of a few seconds. So now I'm going to access both of these databases, and we expect to have same items in both of them. As you can see, also data sync, similar to change data capture, creates some artifacts table on your source database. So you must make sure you have enough space there for that. and we're on the member side because we want to see if that fourth inventory item from the US, the melon, had shown up with this price. And it seems like it did. So both databases are in sync right now, which is great. We just had sync trigger from hub to member, from US to Asia. But now I also want sync from member to hub because I set up bidirectional sync. So I'm inserting a new item in the Asia database. So I insert a dragon fruit there. However, I made a spelling error, so we'll have to fix that. Yes, as expected. So now let's see if this gets redirected to back to the hub in the US. And as I was mentioning, let's see US. You can see this did not show up yet here because there is a sync latency as well, apart from just the frequency. So we wait a few seconds, go back to US, and indeed the dragon fruit shows up here. So this is perfect. We have set up bidirectional replication between Asia and the US, and it all works. So let's move onwards. Great. So one other replication type that I wanted to discuss today is change tracking. So this allows you to record the rows in a table that were changed, but without capturing the actual data that was changed. So if you remember for CDC, you actually also capture historical data changes, but for change tracking, as you can see here, you can see, oh, what type of DML change occurred on each of these rows. So this is pretty much how change tracking works. It records that the rows in a table were changed, but without capturing the actual change data. So there are some key change tracking concepts. So you have a change tracking table similar to CDC. You also have a change tracking functions, some query functions. So these supply the details of the changes in an easily consumed relational format. So for instance, the following functions return information about the changes, such as change table of changes. That's what you would use. This returns tracking info for all the changes to a table that have occurred since the specified version. You can use the change table version function to return the latest change tracking information for a specified row. And then you have an auto cleanup that scans the user databases to identify change tracking enabled databases, and based again on the retention cleaning policy, which is all time-based, each internal on-disk table is purged of any expired records. And lastly, you have the change tracking current version. So every time a user accesses a table, they can ask the version number active at that moment. So you must keep that version number safely stored, and then you can just use that version number the next time you do change tracking to get changes since then. So here, sometimes people mix change tracking and change data capture because they are very similar. So, but there are also some key differences that I wanted to highlight. So for change tracking, it shows which rows have been inserted, updated, deleted, and the net changes based on the version number, as I was previously mentioning. However, change data capture takes the historical data changes. And because of that, on the performance side, this consumes more overhead. However, some similarities are that both change tracking and CDC get enabled at the database level and then at the table levels.
Mara,
yes.
maybe you would like to wrap a little bit?
Yes,
soon?
I'm wrapping up this one.
Okay.
We are at 30 minutes, right?
So we are over 5 minutes.
Oh, we are over 5 minutes. Okay, my slides were saying that we are 29 minutes because I was tracking. Okay, I'll wrap it up very quickly. Sorry. Yes, so both change tracking and CDC can be enabled on the same database, no special considerations required. Great. Here you can see how you can enable change tracking I guess we'll have this slides shared, and you can go through them. Transactional application, we don't have time to go through it. However, the key details here is that you have a snapshot agent, a log reader agent, and a distribution agent. So it's quite different from what we've seen in sync, change data capture, change tracking. And these are some considerations to have in mind for transactional applications. So this is what we discussed today, and here are the scenarios that we looked at very briefly, and some of the solutions. We took some of these solutions out. Hopefully the demos and all the info was helpful to you. If you have any information, feel free to reach out. And yeah, this is all. Thank you.